Ray traces are created by casting out primary rays, which are the green arrows shown pointing away from the origin. These arrows are going to go through a canvas and sees if it can intersect with an object of functions that are going to stack inside one another in order to produce the ray traced image. The first function that we're going to have is the intersect function, which is going to take in for a sphere the center, the radius, the sphere's origin, as well as the direction. And this function is basically going to figure out whether or not the initial ray with a direction and an origin intersects with a sphere. The trace function uses the intersect function and essentially ensures that for every object inside the scene that we've created, the intersect function is carried out, so that no object goes without being returned and having its values put into the final image. The cast ray function is perhaps the most important, because with this function is the return value of the color, which is where we're going to be shading the sphere and actually finally seeing the rendered image. This cast ray function involves all of the equations that we talked about involving reflection and refraction. So when we have these values, we're going to essentially multiply them by the initial color value of the sphere that, say, the user wanted, and then we'll be able to see the shading on the sphere. The next function is the render function, which is going to call. And what this does is deals with the canvas itself. It says that for each pixel in the canvas's width, we have to cast a ray, and inside each of those pixels in the width, we also have to cast a height. And this ensures that